Hello, and welcome to Math 131, Week 3. I'm going to do this week's lesson in two halves, like we've done the previous lessons, but I am trying something new with this week. As we go through Week 3, for at least the first half, we're going to see a lot of plots like this, and for the most part, you all can look at this code or copy it and recreate the plots on your own. But what I'm going to try to do differently here is type out this code by hand. You all will have to suffer through my typos into our standard collab notebook over here. And that way I can try to speak towards each portion of a code cell like this and hopefully give you a better understanding of each new layer of a ggplot plot. All right, so there you go. That's a little bit of what's coming. I'm going to skip over some pieces of the graphing half of this week's lesson, mostly because I think this web page lesson is a pretty good introduction to plotting, so long as you catch the patterns. And that's what this video is mostly going to try to help you see, is the patterns. Okay, so here we go, starting from the top. Import some stuff and get your data frame all prepped. That's what I've already done for you over here. So we're going to copy this line of code here as a comment into our notebook, because it's this line of code that is going to hopefully help us follow the pattern of ggplot plots. So like we did in last lesson, this first piece here is simply about setting up an empty frame. Now I'm referencing capital D, capital F here to say some data frame you have will fill in that placeholder. Effectively, anytime I use all caps is me trying to write in a Python comment like an empty position with capital letters to hint at what type of Python variable should go there. So df stands for data frame. You're to put some data frame in this position. Our data frame for this video is msleep, so you'll see a lot of times we'll start ggplot plots by typing in msleep right here for the keyword argument data in the function ggplot. And then you add on to an empty ggplot plot the geometry of some plot type. So some plot types we're going to go through today are going to be like bar or hist or density. There's also going to be like box. I don't remember if it's box or box plot off the top of my head right now, but anyway, you're going to fill in some plot type appropriate for the variables you have. Within the geom plot type function, you're going to call another function, which is annoying, but that's just how it goes. And you'll specify with x and y keyword arguments some x-axis variable and y-axis variable. Effectively, the aesthetic of some plot type is just saying onto the x-axis, put this variable. Onto the y-axis, put this variable. Most ggplot plots will follow that pattern. Some have extra keyword arguments if you want to start getting fancy, like including a third variable of some kind, or including some grouping variable of some kind. So if you ever get lost in the code that is shortly coming for how to write ggplot plots, hopefully this will help remind you of the general pattern. So let's take it away. We'll start with the plot we saw from last week. It's just a bar chart. So we'll go like this, p equals pn.ggplot. Okay, so here comes the empty data frame. And we're going to pass in the sleep data frame to this empty data frame. And with that empty frame, we will add the geometry of a bar chart onto it. And the bar chart has an aesthetic where you only specify the x-axis variable. And so in this case, we're going to try to use the categorical, that is non-numeric, x-axis variable conservation. So there you have it. There is the exact plot we created last week, just reminding you of the pattern that we're going to see many times in the first half of week 3's video. And the only other thing I'm going to point out here is that in order for me to make this web page, I had to call the plot variable named p. I had to call the function associated with that plot named draw to actually get these plots to show up. That's really just a feature of me having to make this web page for you all. And you can see that we don't need the dot draw at all inside Google Colab. Okay. There is more to be said about ordering the x-axis levels of the categorical variable conservation. I will let you figure that out on your own since the code is written there on the web page. And for the most part, I'm going to move on to the next plot in the name of time. Let's look at a numeric variable equivalent of a bar chart. It's called a histogram. So we will create a new variable p. We're actually overriding the last variable p. I just always name my plots p. We're going to set up the empty frame using whatever data frame we want. In this case, it's our mSleep data frame. We're going to add on the geometry of a histogram. And the histogram has an aesthetic where, again, you only specify the x-axis variable. The difference here is the x-axis variable is now numeric. So if we ask to print the plot p, you can see we get exactly what we have on the web page, including this obnoxious warning, which I will talk about after I explain what a histogram is. So a histogram takes a numeric x-axis variable like sleep total. It effectively sets the range of values for which the variable sleep total takes on. It looks like, let's call it something from 0 to 25. That's not exactly right, but let's just go with that for now. And then it breaks up that range into fixed width bins. So each of these that I'm highlighting with my cursor is a fixed width bin. And the bin heights are the number of data points that fit within each bin. So the bin that goes roughly something 0 to 4, that's kind of off, but again, let's just go with it. The bin that goes from numbers 0 to 4 has, let's say, 11 data points in it. The bin that goes from like just above 4 to, let's say, 8 is, I don't know, maybe that's 9 data points in it. And the bin that goes from like 8 to 12, that looks just past 10. I don't know, maybe that's wrong too, but it's close. The third bin here has 25 data points in it. So what we're seeing here is the shape of the numerical variable sleep total. And that's what a histogram helps us visualize, is the shape of a numerical variable. Later on in the world of statistics, we start calling this a distribution. A histogram is a visual representation of the distribution of the variable sleep total. It is not the distribution, but it is a representation of the distribution. And I'll show you why it's not the distribution of sleep total when we get to the bins argument that this warning is telling us about. From a histogram, we can see things like the width of the data. For the most part, the data shows up between 0 and 25. More data shows up between, let's say, 8 and, 17 than anywhere else. And most of the data is centered around maybe 12. So from this histogram, we get understandings of the range of the data, the general spread of the data, which is separate from the range, like most data is spread out about from 8 to 17. But we also get a visual representation of the measure of center. Most data is centered around 12. You could also almost imagine as if this histogram were balanced at some point. That point at which the histogram is balanced would be a measure of center. Okay, there's our general description of a histogram. Now let's talk about this warning message that shows up. It says it's using the number of bins to be 7. Pick a better value of bin width. So let's just first show you. So here is my cursor. Be very careful with where you're putting your cursor. This is inside geom histogram, outside of AES, and I'm going to say bins is equal to 9. So now you can see 1, 2, 3, 4, 5, 6, 7, 8, 9 bins. Like I say in the notes for week 3's graphing, there is no one right choice for the number of bins. Generally, anything between 7 and 51 are good first guesses. In fact, I don't think 9 is great here. This gap here and this gap here are probably just artifacts of choosing too many bins. For instance, we could just simply change the number of bins and probably see more gaps in the data. Those gaps are a combination of we don't have that much data and we probably chose too many bins. So 7, which it defaulted to, was actually probably a pretty good first guess. There's some obvious wrong choices for number of bins, like 1 and 1001 is probably also too much. If for nothing else, then it took too long to make the plot. From both 1 bin and 1001 bins, we don't get a very good representation of the measure of center or the measure of spread, although it does still include the range of the data. There's no right choice for the number of bins. There are many wrong choices. Generally, in my experience, something between 7 and 51 are good first guesses. You should play around with those when you make your own histograms. Okay. This next plot up is a density plot. It's so closely related to a histogram that I'm just going to copy and paste and change just the plot type here from histogram to density. The only thing it's going to complain about is the number of bins. I should have seen that coming. I didn't. A histogram is effectively like a a density plot is effectively like a smoothed histogram, as if you connected the tops of all of the different bins and then drew some smooth curve over it. It gives you roughly the same sort of information that a histogram does, but it can look nicer in that there is, in some sense, less ink on the page to represent the information there. If I had to pick one of my favorite takeaways from the Edward Tufte books on representing data via plots on visualizations, it would be use less ink to convey the same amount of information. So I think density plots do that well. You can see over here, I won't recreate this one for the sake of time, but you can layer with some special code a density plot and a histogram onto the same plot. It does take some fine tweaking of the y-axis of the histogram, but that's not so bad to see, and then literally it's just a copy and paste anytime you want to do that. This is nice in general that you can do that. So let's see in more scenarios how we can start layering information onto one plot. We will get into bivariate plots. And we'll start with a bar chart that now includes 2 variables. A bar chart that includes 2 categorical variables is effectively like a table with rows and columns. But instead of visualizing it as a table, which is kind of silly because of these zeros, maybe you just have the heights of the bars instead. So we will go down to this plot here. Okay. So for this plot, we're going to do 2 things. We're going to create a new data set using drop NA and remembering that we should always specify the subset argument. We're going to use the variable conservation and var Then we're going to make a plot by starting with an empty frame dependent on our new data frame, df, that we just created on the line above. And then we will add to this plot the geometry of a bar chart, where the aesthetic uses the x-axis variable conservation, and we will fill the bars by the second categorical variable, var, and then we'll print the plot. And other than the ordering, which we figured out in the web page code, but I didn't copy over myself, other than the order of the bars for the plot, that is the same plot as we have before. So that wasn't so bad. You can see you can get really nice features out of ggplots through a simple addition of another keyword argument to the aesthetic function and another categorical variable. The only other thing I'm going to point out relative to the code we have on our week 3 webpage compared to what I made in the video in our collab notebook over here is that you can put multiple lines, you can put your ggplot code onto multiple lines in a code cell. So if we add in, oops, I already added them in. If we add in parentheses starting over here and a right parenthesis ending way over here, you can see they're highlighted blue maybe, then you can put the next layer of your plot onto a new line and everything should work out just fine. Great. This is going to be a feature of Jupyter Notebooks and Python. This is a feature of Google Colab Notebooks and Python that allows you to split up what is otherwise incredibly long lines of code. So we're going to split up this ggplot function into multiple lines to help us read vertically instead of horizontally. Let's see if we can use that below. So next up, it looks like we're going to move to some bivariate numerical variable plots. So we will use that same feature we have to split up a long line of code onto multiple lines. So we'll just immediately start with empty parentheses. And then we'll add in our layer of data frame. And then, oh, right, I see what's coming. X-axis variable and Y-axis variable inside the aesthetic. And then to make a scatter plot of two numerical X and Y-axis variables, we will use the geometry of points. We're effectively adding 1 point for each value in brain weight and body weight. And then we will print the plot. Okay, so there's the same plot that we got on our web page, but let me next attend to the fact that geom point is empty, and instead I took the aesthetic and placed it inside ggplot. Further, I didn't specify the data equals keyword argument. Okay, so we now pointed out all the differences between the plotting style above and the plotting style used currently in our collab notebook. I didn't use the keyword argument data. I put the aesthetic function call inside ggplot, and I've left geom point blank. There's two things going on here. I didn't use the keyword argument data equals here because you can't have keyword arguments showing up before a positional argument like the call to the aesthetic. So I left out data equals. That's probably not the best practice, but it is fairly common in the world of plot9's function ggplot. The next thing I did was actually a move kind of looking ahead into the plots we're about to make, but we might as well explain it here before the plotting gets a little bit more complicated. If you put the call to the aesthetic inside the function ggplot as we have it here, then each next geometry layer will be able to read the x and y axis variables based on how plus works for adding layers of plots. But if you had multiple layers of a plot, like for instance this, and the aesthetic call was right here, then geom other, which I totally made up just for this for the example here, geom other would not understand what x and y axis variables need to be filled in. So it's like if you put the aesthetic in an individual layer, then only that individual layer understands which x and y axis variables need to be put on the x and y axis. But in this case, geom other would give us an error because there is no way for geom other to figure out what the aesthetics of the x and y axis variables is. So another plotting style you can use is to put the aesthetic inside ggplot, and as long as you do that, any geometry following the call to ggplot will understand what the x and y aesthetics are. Okay, that's going to come up below when we try to add more layers of information to this plot. So let's put it in a separate plot, and we'll start adding more information to the plot to see if we can recover this. We'll do it one step at a time, though. So here's the scatter plot between brain weight and body weight. Notice, most obviously for the y-axis variable body weight, the data are some small values. I'm going to guess, somewhere below 100. But then a few of the values on the y-axis extend off to orders of magnitude larger. So imagine values less than 100 have like 2 digits, like 50 for 50 or something. And some of these data extend off into 4-digit numbers. So we're crossing orders of magnitude in the data body weight. Anytime that happens, it's a good idea to at least explore what the relationship between your x and y variables look like on the log scale. So if we add some new layers to this plot that scales, let's just scale both the x and the y-axis variable by log base 10, then you can see there is a much richer relationship on the log scale between the log body weight and log brain weight variables. Now there's an incredibly linear relationship between brain weight and body weight. So effectively, by transforming the x-axis and the y-axis variables by log base 10 just before plotting, you can uncover a deeper relationship between these two variables. That's generally a good idea to explore, whether or not you find anything from it. Now that we have a linear relationship here, we could go about drawing with a smoothing geometry a line of best fit. Whoops, can't type and talk at the same time. Line of best fit, and we'll color it in blue. And you can see how well a line fits these log transformed data. The only other thing I have on the plot on the web page to our right is changing the labels. So we would want to say log of brain weight, and then theoretically there's units to be had here, but I don't know what they are, so I will skip it. I'm not leading by example well here, am I? Log of body weight. And there, we've recreated the plot we have on the web page by adding in new layers of information onto the plot. That's pretty cool. I think there's just a few more numeric plots to go. Oh, density plot, where the density plots are colored by a categorical variable's levels. That's great. I can leave that one to you. That's not too difficult. The last one is a box plot, where the x-axis is categorical and the y-axis is numerical. That's great. Let me explain what one box plot is, and then I'll move on and do the final plot for the, excuse me, I'll move on and do the final plot for the graphing section of this lesson. So a box plot is a visual representation of a numerical variable that helps us understand the shape of the variable and the data within it. So for instance, the y-axis variable here is sleep total. For all of the carnivores, the sleep total has this shape. It's centered somewhere near 12, we'll call that, maybe 11. There seems to be a longer right tail, so the data extend from the median, not the mean, from the median here. The data seem to extend off to large values more than they extend off to smaller values. So we call this like a right tail and a left tail. And then each line here on the box, each of these horizontal lines are a different quartile. This is the first quartile, the 25th quantile that we looked at in the last video. Here's the median, or the second quartile, or the 50th quantile. And here's the third quartile, or the 75th quantile. So we're getting something similar to a histogram, maybe not the same depth of information, just different information. And that helps us understand the shape of the variable sleep total within each level of the categorical variable vor. What's nice is you can do box plots and kind of vertical density plots, which they call violin plots, together. And then you can color them and you can make them fit each other. Let's complete this video by finishing out that plot together. We'll make a new data frame by dropping data from the variable vor. We'll make a plot now using that new data frame. Let's see, you can see on the x-axis is vor. You don't even need to look at the code. And on the y-axis is sleep total. And then these are probably going to fill by vor as well. You can see each level of vor gets its own color. That's indicating that the fill argument is using the variable vor. And then onto a new line. Let's see what we need. We need box plots, but they need to be narrow. Oh, there it is, 0.2, not 0.25. It was a close guess. And then we want a violin plot, and we want violins. Oh yeah, let's make them a little bit transparent so you can see through the violin plot to the box plots. And hopefully you can see that I only cheated a little bit for the transparency of the violin plots and the width of the box plots. And otherwise, this plot all kind of fell together by just looking at what we had. And I think that's really the argument in favor of plot 9 and its ggplotting style, is that you can kind of see, once you learn this little language of ggplot, you can kind of see how the different pieces of a plot fit together to give you really quite a lovely plot.